Guys, for all the solutions of this book, visit forthesakeofeducation.com. I've been working hard of putting all the problems into one convenient place for you to be able to do your homework easily. So pay us a visit.
Alright guys, let's do this problem that says the uniform beam has a weight W and a length L and is supported by a pin at A and a cable BC. Determine the horizontal and vertical components of reaction at A and the tension in the cable necessary to hold the beam in the position shown. Okay, so when you do this kind of problems, it's better to see what they give you. So look at what they give us. They give us W, they give us L, and it's supported at the pin A and cable BC, determine the horizontal. Okay, perfect. So they give us W and they give us L. So what most likely they want us to do is they want us to determine this tension and then this reaction, which is going to be going up and it's going to be going to the left. And I get this by observation. Now, let me call this AY and let me call this AX. Now, why is AX going to the left? Because, oops, almost forgot the weight. Why is AX going to the left? Well, look at T, the tension, is going to the right. So to make up for that, AX is going to be going to the left. If you do enough of these problems, then you would notice that right away. It's all about practice. So since they're giving us W and L, they most likely want us to express AX, AY, and T in terms of W and L. And of course the angles theta and phi. This is phi, right? Yeah, I think this is phi. Because they also give us that in the diagram. So let's get to that. And it's a little bit weird, but don't worry, we'll get through it. Let me make sure. Okay, so assuming counterclockwise is positive, normally what you would do if I gave you values for W and L and the angles, you would start with the sum of the moments at A, because these two, you would eliminate these two and be able to find the tension in terms of the weight and the angles. So sum of the moments at A is equal to 0, and that is equal to first the moment created by the weight. The weight is creating a moment times the distance from here to here. This distance is given by L over 2, which is half of L, times the cosine of theta. And this is negative because it's trying to turn the structure clockwise. Now, the tension has two components. The tension has a y component and an x component. Let's write them down right here, tx and ty. Now, tx is given by t cosine of phi, and ty is given by t sine of phi. Now, let's start with the y component, which is going up, which is t sine of phi, and is turning the moment from here all the way to A. So from there all the way to A is given by L cosine of theta. And this is positive because it's trying to turn the structure counterclockwise. And then the last one is the x component, which I'm going to write down a little down here because I'm running out of space on the tablet. So the x component is given by t cosine of phi, and it's trying to turn the distance from here to A, and that distance is given by L sine of theta. And this is negative because it's trying to turn the unit clockwise. So there we go. Now we have this formula. And with this formula, you notice right away that all three terms, this is one term, this is one term, and this is one term, all three terms have an L, and on the other side they have zeros. So you can eliminate the L's right away, and you would get 0 is equal to minus W cosine of theta over 2 plus, and I'm gonna factorize this side. I'm gonna take out the t outside, and this is sine of phi cosine of theta minus cosine of phi sine of theta. Now from trigonometry you know this term, or you should know this term, and if you don't know this term, I hope in the exam the teacher gives you a cheat sheet that gives you this formula that tells you that sine of theta minus phi is equal to cosine of theta sine of phi minus sine of theta cosine of phi, which is exactly this term. So you could rewrite this as 0 is equal to minus w cosine of theta over 2 plus t sine of theta minus phi, which means that if you solve for t, you get that t is equal to w cosine of theta all over 2 sine of theta minus phi. Now this is important because if you find the a of x and a of y, to find a of x you can do the sum of the forces on the x is equal to 0 and is equal to minus ax plus t cosine of phi. This is equal to ax is equal to t cosine of phi, which means that ax is equal to, I'm going to replace the t by this, which is what we just found, and it's equal to w cosine of theta cosine of phi all over 2 sine of theta minus phi. And then the last term that we have to find is ay, and we know that sum of the forces on the y is equal to 0 and is equal to ay going up minus the weight plus t sine of phi, which means that ay is equal to the weight minus t sine of phi. If you replace t by what we just found right here, you can solve for ay, you're gonna get that, let me write a line right here, ay is equal to the weight minus the weight cosine of theta sine of phi all over 2 sine of theta minus phi. So final answer for ay in terms of the weight, the length, theta and phi, although the length is not really there, and in terms of ax in terms of those four, and the tension in terms of the weight and the angles.